Okay, so here they're saying an object B is on a horizontal surface. Two forces act on B in this horizontal plane. A vector diagram for these forces is shown to scale in the figure below. So this is the figure here. Okay, so they're saying a force of 7.5 newtons towards north and a force of 2.5 north from 30 degrees north of east act on B. The mass of B is 750 grams. Okay, so the first question here, they're saying on the figure, draw an arrow to show the approximate direction of the resultant of these two forces. Okay, so the thing is, you can't draw the resultant without finding the magnitude and its direction. Okay, so first of all, we need to find its magnitude and direction. That's when you can draw it. So we start this question from the second one. Find the magnitude, find the direction, and then you can draw it. Okay, and then the other questions there, they're saying calculate the magnitude of the acceleration B produced, blah, blah, blah. We're going to answer that. So now let's understand this diagram here. So I'll redraw it here. So I have this object B, okay, which is placed like on the X or Y plane like this. So I have a force going due north, so it's coming like this. So it's going like that. So that force is 7.5, okay? And then I have this force here, okay, from 30 degrees north of east. So 30 degrees north of east, it simply means I go to the east, okay? So north of east. So it means you go to the last word there. So east is the reference point. So I go to the east and then I move 30 degrees to the north. No wonder you're seeing this 30 degrees like that. So I move to the east and then 30 degrees to the north. So it makes this guy here. So now take a look at the direction of that arrow. That arrow is pointing towards the origin like that. Okay, it's not pointing the other side. And it has a value of 2.5 newtons. Okay, so if it's pointing like that, it means I can extend it to go in this direction like that. So it's going in this direction. So I can extend it like that. Okay, this is simply 2.5 Newton. All right, and then the angle which is here and the angle that is there is going to be the same because these are just angles at a cross. So I'm sure I remember this rule in grade 12. Say the angle which is there is the same as there. The angle which is there is the same as there. So this 30 degrees here is the same as the angle which is there. So here there's 30 degrees. Okay, so now I've redrawn my diagram, and then now I can find the resultant and its direction. And then once I have that, I can now draw the resultant, right? Okay, so to resolve this, we need to get the magnitude of that vector and the direction from the positive x-axis. So this is the positive x-axis, okay? So for this first, okay, because this one here, this guy here, okay, it continues to go north like that, okay? So for the first vector, is this one, the 7.5. So if I start from my x-axis going here, I'll meet it there. So at what angle is that vector? It is at 90 degrees because this is simply 90 degrees, okay? So I'm going to say my first force, which is 7.5 newtons, is at what? 90 degrees. Then my other force from the positive x-axis, I'll move like this all the way until I find it there. Okay, I'm not going to meet it here, no. Okay, I'm not going to meet it here. So I'm going all the way until there. Okay, because it's going in this direction. Unless it was going in this direction, then I'll meet it there. Okay, so I hope you've understood that. So I'm getting this angle from here all the way up to there. So this angle here is 30. And then from here all the way up to there, that should be what? 180. So 180 plus 30, that would be 210. So the angle is 210. So the magnitude is 2.5 newtons. The angle is what? 210 newtons. 210 degrees. Okay, so with that information now, I can easily sketch my what? I can easily find my magnitude. Okay, so what I need to do here is just simplifying the x component and the y component for each of these. Okay, so I'm going to say x component here. And then y component there. Okay, so the first one is 7.5 cos 90. And then here it's 7.5 sine 90. So what does that give me? So cos 90 is 0. So this guy here is equals to 0. Then sine 90 is 1. So this one is equals to 7.5. Okay, the other one is 2.5 cos 210 is equals to. So 2.5 cos 210. So that one is going to give me minus 2.17. And then on the other side, it will be 2.5 sine 210. So that will be 2.5 sine 210. Okay, so that will give me minus 1.25 like that. So let's add them to get my Rx and my Ry. So here it will just be minus 2.17. Here it will be 7.5 minus 1.25. So that will just simply give me 6.25. Okay, so that is what I have there. So now I can find my resultant. So my resultant is going to be equals to the square root of minus 2.17 squared plus 6.25 squared. So this will just give me what? Okay, so when I punch on my calculator, the magnitude there is giving me what? Okay, it's giving me 6.6 newtons. Okay, and if you check on our question here, they were saying, show that the magnitude of the resultant force on B is 6.6 newton. This is exactly what I find there. Okay, so hence shown. All right, and then now we need to find the direction. Okay, so the direction, we first sketch this. So if this is my X or Y plane, so this is my Y, X, okay? I'm moving minus 2. I'm moving to the left in the X direction because this is minus 2. So I'm moving like this, okay? And then this one is positive. So from where it's ending, I'm moving like that. So I join now my resultant from where I started to where I've ended there. Okay, so from where I've started there to where I've ended there, like that. So the angle, I can find this one here. So let's find that angle. So we're going to find that angle by dividing those two that we have. So it will be theta is equals to tan inverse. Okay, I said even if it's negative, you put a positive. So that will be 6.25 divided by 2.17. So this will be tan inverse of 6.25 divided by 2.17. So that will just give me a 70. Okay, just give me a 70. Is it a 70 now? Okay. Okay. It's going to give me a what? 70. All right. Okay, so the angle there simply going to be 70.9 degrees. So this 70.9 degrees is the angle inside there. Okay, it's the angle inside there. So I'm going to say from here all the way up to there, what am I going to have now? So that will just be 180 minus the 70.9. So 180 minus 70.9. So that will give me 109.1 degrees. Okay, so now we can actually draw the resultant. In fact, this same thing that I've drawn here, that's the resultant. Okay, so the resultant here, if I can extend this like that and then like that, the resultant will be like this. Okay, and then the angle from here all the way to there will simply be 109.1 degrees. Or if you get the angle that is there, you're going to get 70.9 what degrees. Done. Okay, we're done. Okay, we're done. So what else now do we have to do here? Okay, nothing else. All right, so we've sketched this. That's the sketch. We've shown that the resultant is this. And then B, they're saying calculate the magnitude of the acceleration of B produced by this resultant force. So the resultant force is 6.6 newtons. So now remember the formula. Force is equals to mass multiplied by acceleration. So acceleration is equals to force over what? Mass. But this mass here has to be in kgs. So it will be, the force is 6.6, and then the mass here was given 750 grams. So I divide it by 1,000 to change it into kilograms. So it will be 0.750 kgs. So I'm going to divide by 0.750 kgs. So my acceleration there will simply be, okay, I just divide those two that I have. Okay, so that will be 6.6 divided by 0.75. So my acceleration will be 8.8, okay, meters per squared second. Okay, so that is my acceleration. And then here on part 4, okay, so on part 4, they were saying what? Okay, on part 4, they were saying, okay, on part 4, they were saying, determine the angle between the direction of the acceleration and the direction of 7.5 Newton force. So the 7.5 Newton force, you can see is here, right? And then the direction of the acceleration is in this force here. That's the resultant force. So they want the angle between the direction of the acceleration and the direction of the 7.5 force. So it means they want this angle here. Okay, so how are we going to find that angle? We know that the angle from starting from here up to down here is 70.9. So I also know that starting from at this point here all the way up to down here, that angle should be 90. So to find this, I'm just going to say that angle, okay, will just be 90 minus 70.9. So this will just give me, okay, so 90 minus 70.9, 90 minus 70.9, this gives me 19.9 degrees, 1 degrees, I mean. Okay, so that is the angle that will be there. All right, so the angle will just be 19.1 degrees between the direction of the acceleration and the direction of the 7.5 newtons force. All right, so we are done with this question. Okay, so for those who have further questions or you need your tutorial sheet to be solved, you can easily send it on this number. So 0779 96 40 10. Okay, so that is Tutor Post Solutions. You're going to find me there. So you can send me your tutorial sheets. Okay, I'll be able to solve them, and then you can access them on our website. So we have a website and a mobile app that has a lot of information that can help you as you're doing your first year. We have solved tutorial sheets, we have solved past papers, we have topic lessons, okay, for different topics in math, chemistry, physics, and biology. So you can register and you'll be able to access them on the website. Okay, so let me show you the website for those who do not know it. So I was solving questions from this tutorial sheet here. So this tutorial sheet has how many questions? So I started from question 1. Okay, so from question 1 here to dimensional analysis, there was uncertainties, there's unit conversions, there are vectors here. Okay, I've solved all the questions up to question 12. So this was the last one here, the one we're from solving, question 12. So if you like to access the videos, full solutions, you can actually just go on the website and access them. Okay, so to go on the website, just open your Chrome, and then in the Chrome type discretelearning.com and then say go. So that website is going to open up here. So if you do not have an account, just click subscribe to course. And then here, okay, if you do not have an account, you come here and you create an account. Okay, So put in your name, your email, set your password, the university, put it there, create an account, and then this window will come up. So you put your email there and then your password there. Then you say login. Okay, so once you log in, it will lead you to these courses here. So this is mathematics, chemistry, physics, biology. So you can choose any of the courses that you want to register for. So if you haven't registered here where it's written enrolled, there's going to be an orange icon there. It's going to be not enrolled. So make sure you enroll for it, for the course that you want, and then make sure that it changes to green. Okay, and then you can open it, you can find whatever you want. So for example, if I open, let's say the math folder here, then you go to this folder, general mathematics. Okay, and then you go to topic lessons. You're going to find the topic lessons there. So you can see well arranged, set theory, real numbers, surds and rationalization, rational and irrational numbers, binary operation, complex and imaginary numbers, quadratic functions. All the videos here are available for you guys to study at your own time, at your own pace, even in your what? Even in your blankets. Okay, and as well as when you go to the tutorial sheet, let me show you. So when you go to the tutorial sheet here, it will depend at the university where you are. Okay, so if you are from CBU, go to the folder for CBU. If you are from Mukua, go to the folder for Mukua. Okay, in fact, you won't even be able to see the other folders. You just see the folders for your university. So if you're from Mukua, for example, you can go to Mukua. Okay, then you come, this recent intake is 2025-2026. So you come there, you open it, okay, and then you go to tutorial sheet 2. So this tutorial sheet 2 here, you can see all the questions have been solved from 1 to 25, and they are waiting for you here. So if you're finding it difficult to understand things, we have simplified them here. So even tutorial sheet 2 is solved as well. Even the tutorial sheet for physics are solved. They are there, the videos are there for you to watch anytime, anywhere, even in your blankets. Okay, so it's a very good platform. And as a bonus, we also have a mobile app. Okay, so the mobile app, just go on Play Store and search it, Discrete Learning Institute. So on this mobile app here, you'll be able to download all these videos that you can see here, and you'll be able to watch them what? Offline. So it's a voila. You don't always need internet to learn with us. So you can download, once you go where there's Wi-Fi, download, download, download. Then when you go to your boarding house or your room, you simply watch offline and then you enjoy. Okay, so make sure you tell your friends about this, okay, because it will be very helpful even to them as well as to you. So make sure you subscribe, access everything here, and then at your own pace, at your own time. Okay. All right, guys. So thank you so much for watching. This has been Tutapo Solutions. Until next time, always there for you.